Yes. Next topic is hybridization. In the last class we discussed about the covalent chemical bond. During the formation of the covalent chemical bond, the sharing of the electrons that occurs between two atoms, where each atom contributes only one electron for the bond formation. Whereas if two electrons are shared, then a single covalent chemical bond is formed. If suppose the four electrons are shared between two atoms, two from each, then two covalent chemical bonds are formed. Now during the formation of the covalent chemical bond, the electrons from the different atomic orbitals are shared. Whereas S and S atomic orbital, or P and P atomic orbital, in particular Px atomic orbital, or Py atomic orbital, or Pz atomic orbitals. Now S overlapping. For example, in the hydrogen molecule formation, whereas the hydrogen has one electron and the neighboring hydrogen has one electron. Therefore, the hydrogen molecule is formed by means of the sharing of the electrons between two hydrogen atoms. Now this electron is present in 1s atomic orbital and this electron is present in 1s atomic orbital. Therefore, it is called S and S overlapping. It is called S overlapping. Here in 1s means 1 is corresponds to the main energy level. 1 corresponds to the main energy level. This S that corresponds to the shape of the atomic orbitals. Shape of the atomic orbital. Shape of the atomic orbital. Whereas for first hydrogen atom, main energy level is same and the shape of the atomic orbital is also same. For this second or neighboring hydrogen atom, the main energy level is same and the shape of the atomic orbital is also same. In such cases, the overlapping is not a problem. In case of the chlorine molecule formation, there is a Cl2 that is formed by means of the two chlorine atoms. Whereas the electronic configuration of the chlorine atom, there is a 2p2 2p5 electronic configuration. 2p2, that is 3p2 1s2 2s2 2p6 3s2 3p5 configuration. And the neighboring chlorine atom also having the same electronic configuration, that is 1s2 2s2 2p6 and 3s2 3p5 configuration. According to Hund's law of maximum multiplicity, the p5 electrons, that is 3p5 configuration, whereas p atomic orbital has 3 subatomic orbitals. This is 3p5 atomic orbital. This is for this 3p5 atomic orbital. Neighboring has 3p5 atomic orbital. Now this is px atomic orbital and py atomic orbital and pz atomic orbital. Px atomic orbital and py atomic orbital and pz atomic orbital. Now according to the Hund's law of maximum multiplicity, first we have px atomic orbital 1 electron, py atomic orbital 1 electron, pz atomic orbital 1 electron. Next, 4th electron and the 5th electron will occupy. Now this pz atomic orbital is involved in the chemical bond formation. That is called 3pz atomic orbital. Here also neighboring chlorine atom, px 1 electron, py 1 electron and pz 1 electron, and the 4th electron occupies the px and 5th electron will occupy the py atomic orbital, and unpaired electron is present in pz atomic orbital, that is 3pz. In particular, this most precise word is 3pz atomic orbital. Just see here, main energy level is same, that is 3 and 3, and the sub energy level is also same, that is a pz and pz. Therefore, energy of the two atomic orbitals and the shape of the two atomic orbitals and orientation of the two atomic orbitals are same. Just here, energy 3pz atomic orbital, energy level, that is third main energy level, and pz atomic orbital. Here, shape and orientation of the atomic orbital. Here 3pz overlapping. 3pz for first chlorine atom and this 3pz for the neighboring chlorine atom. Both are same. In such cases, the formation of the covalent chemical bond, that is the frequency or the wavelength of the both the atoms are same, or both electrons are same, who are involved in participating in the chemical reaction or chemical bond formation, and hence there is no problem in the formation of the covalent chemical bonds. Therefore, in all these cases where the homomolecules are formed by means of the two different the atoms of the two different energy levels, that is the same energy levels. In such cases, the formation of the covalent chemical bond has no problem. Whenever, if the main energy level associated with an electron and sub energy level associated with the electron are different, and in some cases orientation of the atomic orbital is different, then during the covalent chemical bond formation, we need the mixing up of the half-filled atomic orbitals. The phenomena is called hybridization. Is it clear? Now, what is hybridization? The process of mixing up of the half-filled atomic orbitals of different energy levels and different in shapes in order to give the new hybrid atomic orbitals of equal in energy level and equal in shape is called hybridization. Hybridization means, it is simple terms, it is nothing but the process of mixing up of the half-filled atomic orbitals. Very simple terminology. Mixing up of the half-filled atomic orbital phenomena is called hybridization. Which type of the half-filled atomic orbitals? Whether two atomic orbitals or more than two atomic orbitals, they possess same main energy level or same shape of the atomic orbitals and same orientations are participating? No. Very important, whenever the main energy levels are different, whenever the shape of the atomic orbitals are different, whenever the orientation of the atomic orbitals are different, then only we will follow the mixing phenomena or hybridization. Is it clear? Yes. It is a process of mixing up of the half-filled atomic orbitals. Process of mixing up of the half-filled atomic orbitals. Half-filled atomic orbitals. Of different in energy levels. and different in shapes and also orientation. In order to form new equivalent atomic orbital. Equivalent atomic orbital this is called hybrid atomic orbital. Hybrid atomic orbital. Equivalent atomic orbital having equivalent shape. And nearly same energy level. Nearly same energy level. This is almost same energy level. This is almost same energy level. Is it clear? This phenomena is called hybridization. Now in your syllabus we have 3 hybridization. First one is called sp3 hybridization. sp3 hybridization. sp2 hybridization. And sp hybridization. sp hybridization. Now we have 3 types of the hybridization in your syllabus. sp3 hybridization, sp2 hybridization, sp hybridization. Very important hybridization included in your syllabus. Now what do you mean by sp3 hybridization? sp3 hybridization. sp3 hybridization. Here how many s atomic orbitals are there? Here you have one number of s atomic orbital. One number of s atomic orbital. And 3 numbers of p atomic orbitals. One number of s atomic orbital and 3 numbers of p atomic orbitals. That is equal to 4 numbers of sp3 hybrid atomic orbitals. Hybrid atomic orbitals. 4 numbers of sp3 hybrid atomic orbitals. Now this phenomena is called sp3 hybridization. The process of mixing up of the 1 number of the s atomic orbital and 3 numbers of the p atomic orbitals. 3 numbers of the p atomic orbitals means px plus py plus pz. This is called 3 numbers of the p atomic orbitals. Here 1 number of the s atomic orbital means this is simply s atomic orbital. Therefore here s plus px plus py plus pz all are different in energy levels and different in shapes. Then it gives rise to 4 numbers of sp3 hybrid atomic orbitals. sp3 hybrid atomic orbitals. sp3 hybrid atomic orbitals. Is it clear? It is like that of the mixing up of the 1 can red paint and 3 can white paint. It gives rise to the 4 can pink paint. Just imagine 4 different walls are here. First wall, second wall, third wall, fourth wall. Assume you have 4 can paints, but out of this 4, 1 can red paint and 3 can white paint. Assume. Is it possible to complete paint to this by means of red and white and white and white? No. What you are doing? You are taking one big container and you are pouring 1 can red paint to the big container, and second can white paint and third can white paint and fourth can white paint to the big container with constant stirring. Then it gives the new color, that is pink color. New color means the pink color. Now this is hybrid color. This is called hybrid color. It is nothing but 1 can red paint, 1 can red paint plus 3 can white paint, 3 can white paint, that gives rise to 4 can pink paint, that is equal to 4 can pink paint. In this 4 can pink paint, red intensity will be 25%. White intensity will be 75%. White intensity will be 70%. Quarter of the red color and 3/4 of the white color will be there in such pink paint. The same phenomena is applying here. By mixing up of 1 number of the s atomic orbital and 3 numbers of the p atomic orbitals, then it gives 4 numbers of the sp3 hybrid atomic orbitals. Then what about the s character and p character? What about the s character and p character? One number of s atomic orbital, 1 number of s atomic orbital plus 3 numbers of p atomic orbitals, that gives rise to 4 numbers of sp3 hybrid atomic orbitals. Hybrid atomic orbitals, which is like that of s plus, px plus, py plus, pz. That is equal to 4 numbers of sp3 hybrid atomic orbital. sp3 hybrid atomic orbitals. Here what about the s character? S character is 1/4 and p character is 3/4. S character is equal to s divided by s plus px plus py plus pz. S character, percentage of s character into 100, that is equal to 1/4 into 100, that is 25% s character. 25% s character. What about the percentage of p character? Percentage of p character, that's a px plus py plus pz divided by s plus px plus py plus pz. That is equal to 3 divided by into 100 into 100. That is equal to 3 by 4 into 100. 1 plus 1 plus 1, that is equal to 3. 1 plus 1 plus 1 plus 1, that is equal to 4 into 100. That is equal to 75% p carat. Therefore, in sp3 hybrid atomic orbitals, we have 25% s character and 75% p character. 25% s character and 75% p character. Okay. See here, this is S atomic orbital. You know that S atomic orbital is a spherical shaped atomic orbital, sphere shaped atomic orbital. S atomic orbital is a sphere shaped atomic orbital. This is S atomic orbital. One number. Plus p atomic orbital. You know the shape of the p atomic orbital? P atomic orbital is a double shaped atomic orbital. This is px atomic orbital because it orients along x-axis. This is px atomic orbital. This is y-axis and this is z-axis. This is z-axis. Assume this is 3 numbers of the p atomic orbital. 3 numbers of p atomic orbitals. 3 numbers of p atomic orbitals. This is one. Just imagine one more which orients along y-axis. Imagine one more which orients along z-axis. This dome shaped is along y-axis, it is called py atomic orbital. If this dome shape along z-axis, then it is called pz atomic orbital. On board I mentioned only one, that is the px atomic orbital. Just imagine similar type of the py atomic orbital and pz atomic orbitals also there. Okay, by mixing up of these, that is called px atomic orbital. Now we have after mixing Here one electron will be there. Here one electron will be there. Now this 4 electrons. This type of the 4 numbers of the hybrid atomic orbitals. This type of the 4 numbers of the hybrid atomic orbitals. 4 numbers of hybrid atomic orbitals. 4 numbers of hybrid atomic orbitals. This is called sp3 hybridization. sp3 hybridization. sp3 hybridization. Is it clear? sp3 hybridization. Now this is about how the hybridization occurs in mixing up of the 1 number of the s atomic orbital and 3 numbers of the p atomic. Just imagine this number of the 4 hybrid atomic orbitals will be there. 4 numbers of the hybrid atomic orbitals will be there. Now all these 4 numbers of the hybrid atomic orbitals, they orient at an angle of 109 degree 28 minutes. This is one sp3 hybrid atomic orbital, 1 number. Second sp3 hybrid atomic orbital, 1 number. Third sp3 hybrid atomic orbital, 1 number. And fourth sp3 hybrid atomic orbital, 1 number. See, in methane molecule formation, usually valence of carbon electronic configuration 1s2, 2s2, 2p2 configuration. The first energy level already occupied by mass of 2 electrons. In second energy level, this is 2s atomic orbital, 2s atomic orbital, and 2p atomic orbitals, 3 numbers. This is 2p atomic orbital. 2s atomic orbital always 2 electrons, 2p2 configuration 1 and 2, and it has a vacant atomic orbital. This is a px atomic orbital, this is px atomic orbital. Second column is 2py atomic orbital, third column is 2pz atomic orbital. Now, according to this, valence of carbon atom is 2. According to this, valence of carbon atom is 2 because the total number of the unpaired electrons present in higher energy level atomic orbitals are called valence electrons. But during chemical bond formation, this is ground state electronic configuration. This is called ground state electronic configuration. This is called ground state electronic configuration. Whenever chemical reactions occurs, we are providing energy. When they acquire energy, this is 2bx and this is 2py and this is 2pz, 2px, 2py. One of the electron from 2s atomic orbital is promoted to the vacant pz atomic orbital. Now 4 electrons are available for bond formation. This is excited state electronic configuration. Excited state electronic configuration. In excited state electronic configuration, this is electronic configuration on the basis of the handful of maximum multiplicity. During chemical reactions, whenever energy is supplied, one of the 2s atomic orbital electron will get unpaired and it is shifted to the vacant pz atomic orbital. Now the excited state electronic configuration is 2s1, 2px1, 2py1 and 2pz1. Now here see, this is s atomic orbital 1 number and p atomic orbitals 3 numbers. Now it leads to the formation of the 4 numbers of the sp3 hybrid atomic orbitals. sp3 hybrid atomic orbitals. Is it clear? Now mixing up of all these, that is a 2s plus 2px plus 2py plus 2pz. Here main energy levels are same, but sub energy levels are different in energy levels and different in shapes. Then it leads to the formation of 4 numbers of sp3 hybrid atomic orbitals. That is our methane molecule formation. Now here it has 1 electron in each atomic orbital, therefore it needs 1 more electron for the bond formation. Each atomic orbital that requires 2 electrons that conforms the octet state. Therefore, they acquire 1 electron from that of the hydrogen atom. Just here, this is carbon, this is hydrogen. Now this hydrogen has 1 electron, hydrogen having 1 electron. Assume this hydrogen having 1 electron and this is hydrogen having 1 electron and here 1 more hydrogen having 1 electron. 1 hydrogen having 1 electron. Now this s atomic orbital of the hydrogen has 1 electron, s atomic orbital of the hydrogen has 1 electron, s atomic orbital of hydrogen has 1 electron and s atomic orbital of the hydrogen has 1 electron. Hydrogen needs 1 electron for the octet state and this sp3 hybrid atomic orbital also needs 1 electron for the octet state. Therefore, they overlap with one another. Now they overlap with one another. Now this is 1 electron from the carbon atom, sp and 1 electron from that of the hydrogen atom. Now this is sp3 overlapping. And here 1 more electron from the carbon atom sp3 hybrid atomic orbital. S atomic orbital here. Now this is S atomic orbital. This is sp3 hybrid atomic orbital. This is S atomic orbital. This is sp3 hybrid atomic orbital. This is S atomic orbital. This is sp3 hybrid atomic orbital. This is S atomic orbital. This is sp3 hybrid atomic orbitals. Now 4 covalent chemical bonds are formed. This S stands for hydrogen. This S stands for hydrogen. Now this S stands for hydrogen. This S stands for hydrogen. Now this orients at an angle of 109 degree 28 minutes. It orients at an angle of 109 degree 28 minutes. Now when we combine all this is sp3 hybrid atomic orbital. It is sp3 hybrid atomic orbital. This is one sp3 hybrid atomic orbital, and towards an observer, this is a dotted line that stands for towards an observer. Towards an observer. Now this is hydrogen, and this is hydrogen. You join all this, and this is hydrogen, and this is hydrogen. You join all this, and you join this part, and you join this part. Now assume this carbon is there at the beginning, middle, carbon is there in the middle, and these are hydrogen atoms, corner of the tetrahedral shape. This is hydrogen, and this is hydrogen. Now this is called tetrahedral shape. Tetrahedral shape. Tetrahedral shape. Now this bond angle that corresponds to 109 degree 28 minutes. Bond angle is equal to 109 degree 28 minutes. Bond angle that is equal to 109 degree 28 minutes. This corresponds to the tetrahedral bond angle. This corresponds to tetrahedral bond angle. Tetrahedral band angle. The power of the P that determines the geometry of the molecule, which is equal to 3-dimensional geometry. 3-dimensional geometry. Three-dimensional geometry. Now this is about the shape of the atomic orbital and geometry of the molecule. Geometry of the molecule. Now what about the type of the hybridization in the methane molecule or any saturated carbon atoms? Not only methane molecule. Methane is a saturated hydrocarbon. Therefore, if the carbon atom that forms a covalent chemical bond with a neighboring atom by means of the single covalent chemical bond, then it would be sp3 hybridized. In methane, we have sp3 hybridized carbon. Yes, sp3 overlapping. Yes, sp3 overlapping. 4 numbers of the sp3 overlapping are there. 4 numbers of carbon, hydrogen, covalent chemical bonds are formed. Carbon, hydrogen, covalent chemical bond. Covalent chemical bond. Bonds are formed. There is a HCH bond angle. HCH bond angle in methane that is equal to 109 degree 28 minutes. 109 degree 28. This is about the shape of the methane molecule. Is it clear? methane molecule formation, the carbon atom electronic configuration is 1s2, 2s2, 2p2. Its ground state electronic configuration is like this. Where is it? 2s2, 2px1, 2py1, 2pz1. Whenever the chemical reactions that will occur, then we need energy. Therefore, after supplying energy only the chemical reactions will occur. Then one of the electron from the 2s atomic orbital is excited to the higher energy level atomic orbital, that is a 2pz vacant atomic orbital. Therefore, the new electronic configuration, excited electronic configuration of the carbon atom would be where the 2s1, 2px1, 2py1 and 2pz1. Now we have 2s one number of the atomic orbital, 2px and 2py and 2pz, 4 numbers of the atomic orbitals are there. Then the mix up, then it leads the formation of the 4 numbers of the sp3 hybrid atomic orbitals. All the 4 numbers of the sp3 hybrid atomic orbitals, they orient at an angle of 109 degree 28 minutes like this. Each sp3 hybrid atomic orbitals, they have only one electron. Therefore, they are seeking for more electron for the covalent chemical bond formation or in order to get the octet state. Therefore, all these 4 hydrogen atoms of the methane molecule, they have one electron. Therefore, one electron from the hydrogen and one electron from the sp3 hybrid atomic orbital, they form one covalent chemical bond. Therefore, sp3 overlapping, that leads the formation of the one sigma covalent chemical bond. Whereas the covalent chemical bonds are different types, sigma covalent chemical bond. This is axial overlapping of the half-filled atomic orbital. Where the half-filled atomic orbital, this is half-filled atomic orbital, the axial overlapping will occur. Half-filled atomic orbital, half-filled atomic orbital, axial overlapping will occur. Half-filled atomic orbital, half-filled atomic orbital, axial overlapping. Axial means along the axis. Along the axis overlapping will occur. Then it leads to the formation of the 4 types of the carbon, hydrogen, sigma covalent chemical bond. Very precise, it is a sigma covalent chemical bond. Now, in geometrical fashion, we can write the shape like this. Whereas the middle is carbon, this is hydrogen, this is hydrogen, this is hydrogen, this is hydrogen. They orient at an angle of 109 degree 28 minutes. 4 numbers of the carbon hydrogen covalent chemical bonds. Preferably, this bond is called as a sigma chemical bond. Sigma covalent bond. Sigma covalent bond is formed. Is it clear? And the bond angle is 109 degree 28 minutes. Now, what about the sigma covalent chemical bond? Covalent chemical bond which is formed by axial overlapping of the half-filled atomic orbital is called sigma covalent chemical bond. Sigma covalent chemical bond. Sigma covalent chemical. Is formed by axial overlapping of the axial overlapping of the half-filled atomic orbitals. Half-filled atomic orbitals. Therefore, 4 numbers of carbon, hydrogen, sigma chemical bond. Four numbers of carbon, hydrogen, sigma covalent chemical bonds are formed. This is about the sp3 hybridization. Thank you.